So in this video we're going to sketch or attempt to sketch a sinusoidal cylinder. So sketch the surface represented by z equals the sine of x over the interval from 0 to 2 pi. So when I look at this, I want to recognize that the y variable is missing. So I'm going to need to draw things parallel to the y-axis. And then I want to think about z equals the sine of x. So if I think about the xz plane, the sine function on the interval from 0 to 2 pi is going to start at 0. It's going to go up to 1, back down to 0, down to -1, and at 2 pi it'll be back at 0. So this will be at 2 pi. This high point happens at pi over 2. It's at 0 at pi. The low point at -1 happens at 3 pi over 2. So I have a curve in the xz plane, and then I would draw lines through this curve parallel to the y-axis to create my sinusoidal cylinder. So step one would be to go ahead and draw, to the best of your ability, in the xz plane the sine function on the interval from 0 to 2 pi. So I would start at the origin, I would go up at pi over 2, I would be at my highest point, and then I would drop down to 0 at pi. At 3 pi over 2 I'll be at my lowest point at -1, and then at 2 pi I'll be back at 0 if I'm talking about the sine function. And then what we would do is draw lines usually through the key points like the peaks and the intercepts, but those lines would need to be then parallel to the y-axis because the y-axis is the missing variable. So drawing a line parallel to the y-axis, which isn't always easy to do without a ruler, parallel to the y-axis, parallel to the y-axis, trying to be parallel to the y-axis. And then what we want to recognize is the sine function is going to repeat itself over and over again, infinitely many times, using these key points. So this is going to drop back down. The y-axis itself is going to be one of the parallel lines. And we'll get this sine function repeating itself, and the set of all of those sine functions put together will create the cylinder, or alternatively we can think of this as the set of all lines parallel to any one of these given lines is going to create the sinusoidal cylinder. In Geogebra it's much simpler because we simply go into the 3D view mode in Geogebra. I've set my x-axis so that it has pi over 2 based tick marks, and then if I type the function z equals the sine of x, which has the y variable missing, you'll see that Geogebra is going to generate the sinusoidal cylinder from me. When I look at it face on in the xz plane, what I see is just the sine function. And of course Geogebra is drawing it from -infinity to infinity. We would only be drawing it from 0 to 2 pi, and then extruding the lines parallel to the y-axis to complete the cylinder. So Geogebra is giving us more than what we're asked to do here. This would be a pretty reasonable representation of that cylinder, I think.